Now, we do filtering, and this is part of the standards, and this is often in our sort of vocabulary. So we filter out typically two scales to get at the roughness, a larger scale and a small scale. So here might be the roughness on the full range of wavelengths in a surface measurement. So these finer scales, sometimes we call them noise. Sometimes they're filtered out because people like to use calculus and pretend that what they're looking at is a function that they can write down, in which case then we've got to get rid of some of the choppy stuff. So the next largest scale would be waviness, and then the next largest scale would be form. So waviness also takes out a chunk, and sometimes the upper end of roughness can equal the lower end of waviness. I think that's usually the case, but it doesn't have to be that way. So what we're looking at when we look at roughness, by definition in the standards, is a range of scales between this very fine scale that is often filtered out and then the boundary often with waviness. So form would be, like it's cylindrical. Now waviness, the one thing that I've heard that waviness is a good predictor of is noise and bearings. So this is at a larger scale. The roughness can be very important for holding lubrication, say, in bearings. And so these are effective in some things, particularly in the automobile industry, and sorting this out. And that's because the automobile industry had so much impact over development of standards, particularly coming out of World War II, when a lot of this stuff got developed, and particularly in the United States. So here we can see there's the profile that we were looking at before for a turned surface. And here with a certain, and here's the filters for this waviness. And so we can kind of see, yeah, the waviness fits. And then what's left over basically is the roughness. Slightly different symbols are used here. So there we have the actual measured surface, the waviness that's filtered out to get us to the roughness. Now, if we take a look at the filtering, filtering can have a large impact on the result. And often at high-level international conferences, I've seen people present roughness results, and you ask them, so what did you use for a cutoff filter for the roughness? A very important question. So often these researchers throw in roughness and have little idea what they're talking about. And this is one of the manifestations of it. If you don't report the filtering cutoffs, you really haven't told us anything meaningful. So by changing the filter cutoff from 0.25 to 0.8 millimeters, the average roughness changes 41%, and this is what people report. So if you don't tell me what the cutoff filter was, your results are kind of meaningless.